Hello YouTube, this is my series hybrid golf cart based off of a E-Z-Go Cushman Hauler Pro, and I wanted to make a video documenting how it works and why I would ever make something like this. But let me go ahead and open it all up and I can talk about what's going on inside. So here it is with the seat removed and the bed up. Please ignore my piece of wood. I had to raise the seat and I'll come up with something better later, but that's just what I've got for now. And you can see my Curtis handheld programmer, which I'll explain the importance of that in a little bit. But basically this cart, I had this idea a long time ago because I'm interested in the series hybrid concept, like how locomotives or ships work, or even this John Deere 7700 fairway mower, which I'll talk about in a little bit. This is kind of where I got the inspiration on how mine is set up. But basically this is an old electric Cushman Hauler Pro, so we can kind of look at the things that are original to the cart. So this controller, which is a Curtis controller, a 1234 SE. I don't know if you can kind of barely see it. That's original to the cart along with its motor. The difference is there used to be batteries here. There would be 9 8-volt batteries to make a 72 volt pack. And now instead I've replaced it with a petroleum battery, which is coined by another YouTuber who did something similar. I'll put the name of the channel somewhere on the screen. But so instead of batteries, we basically have, you can think of it like a generator. So we've got a small engine. This is just a Harbor Freight Predator 420cc engine, and all it does, as you can see from that belt there, is drive this alternator. Now this is a special alternator. It's not like a car alternator. It's a Cushman, and it says there 48 volt alternator. Although Cushman didn't intend it to be used like this, the 48 volt alternator is actually meant to be used to charge 48 volt batteries. So it actually puts out 57 volts to put out more voltage in the battery. So for now we'll refer to it as a 57 volt alternator because that's actually what it is. So when I got this idea originally, I thought it would actually be really simple, and don't we all? I thought I would literally just take an engine and an alternator, something just like that, and just literally connect the output from the alternator to the same battery connections that were already here, and remove the charger, which used to sit somewhere in there, and then it would be good. But it's actually not quite that simple at all. So really, Cushman kind of saved me just planning this, because originally I couldn't really find a good alternator of this style. So this alternator works like an automotive alternator, so it is not a permanent magnet generator. It is a alternator that uses a electromagnetic field in the rotor as opposed to permanent magnets. That's how it regulates the voltages, by varying the intensity of the electromagnetic field in the rotor. And to find an alternator set up like that regulates itself at anything but above 12 volts at any kind of decent output is not easy. Originally I was going to go to Alibaba, which is lame, and I'm glad I didn't. But they have some offerings there. I have no idea how reliable or good they are. But then I stumbled across Cushman. Now Cushman, because they're, these alternators, they don't mass produce them. They make them, to order. Because of that, they make you fill out a form to confirm what you're going to do with it, and they intend for you to charge batteries. So they make you fill out a form that make sure that the batteries you want to use it with are compatible. That way you don't end up returning it. Now, of course, I'm not using it for batteries, I'm using it for this. And so, I emailed them that. I said, well, this is what I'm doing with it, so just go ahead and make it, right? I'm confident in what I'm doing. And they actually gave me some advice. They told me not to do it, which is funny. And the reason they told me not to do it is because, I had to learn a lot, really, about kind of electricity and the type of electricity an alternator puts out. So they told me kind of two key things that I didn't really think of. Number one, the output. Here, let's go ahead and step over here. The output from the alternator is, not clean power. It's not, and I knew this already. It's, an alternator puts out three-phase alternating current. It gets rectified, and you get what they call AC ripple. It's not clean, smooth DC. It's a little bit dirty, as they say. And the second thing is the voltage regulator is not perfect. Let me clarify. They're saying these things without batteries. With batteries, the batteries act as kind of a big filter. They clean up the DC power and they kind of help stabilize the voltage. They take the, peak, demands and dips in current and stuff like that. They handle the change in current that the alternator by itself doesn't do so well. So without batteries, the other thing the alternator will do besides the AC ripple is it'll have kind of severe voltage fluctuations, especially under sudden current demands, and then after having a high current demand, a sudden loss of current demand, right? Dropping back to maybe 0 amps drawn. In this golf cart, that's going to happen frequently because maybe, as you floor that pedal there, you might demand full power, and then once you let go, you go back to demanding nothing. And so you're going to have big voltage fluctuations. And they told me, this isn't going to work, and understandably so. I was kind of, the reason I persevered though is because of this unit right over here. So this is a John Deere fairway mower. It's an E-cut mower. Now, E-cut is referring to the fact that these cutting units here use electric motors. And you can see they're, wiring harnesses. That's what goes to these electric motors. There's one on every unit. There's 5 cutting units on this mower. And I've always been a fan of these mowers. Now, the reason they're E-cut, the alternative to E-cut, the traditional way, would be a hydraulic motor. And the reasons for switching are specific to golf, and I won't get into that. Maybe I'll make a video on golf course equipment later. But the way these work is kind of exactly what I want to do. So if we raise the hood here, you can see there's a Tier 4 3-cylinder Yanmar diesel. And all of that power, there's no special batteries, there's no nothing. There's just an alternator right there. And to clarify, this mower, the only battery that's on it is a standard 12-volt battery to start the engine, run the computers and normal things that this mower would typically have. It even has a standard 14-volt, I believe, like 55 amp. Yeah, it says right there, 14-volt 55 amp alternator to charge your battery, and those two things are standard on all of these mowers. This alternator over here is a separate alternator. This alternator is actually quite impressive, more impressive than the one over there. It produces 56 volts, just like mine, but 240 amps. I believe the Mechman one makes a peak of 160 amps. So this one actually puts out significantly more, and it's also a lot bigger, as you can see. And it's driven off the rear of the engine with a 8-rib, serpentine belt. And that alternator produces the power directly for these motors without any batteries or capacitors. There's no batteries on this, other batteries on this machine. And if you follow this wiring harness, and of course I've looked at schematics because I've nerded out about this stuff, but these positive and negative leads simply go around the mower and they connect to each one of these motor controllers. There's one per per cutting unit. So there's one there, there's one there, there's going to be one in the middle, going to be one there, and the last one is going to be under here somewhere. Yeah, right there. And those power and ground from that alternator is just these two. Let me get to a better one. I'm just connecting to those two leads right there. That's all that alternator does. It goes straight to those motor controllers. And then of course these are brushless motors. Those motor controllers invert the DC power into 3-phase AC, which is exactly what's happening over here. We got the same thing. We got power, positive and negative, going straight to the controller. The controller inverts the power to 3-phase for the motor. So how does John Deere do it then? Is there something special about this alternator that's different than mine? The answer is no. The answer is actually simple and yet not simple. The simple answer is that the motor controllers can handle the AC ripple and the voltage fluctuations. So these mowers have a info center here, and you can actually watch the E-cut voltage as you're mowing. And when you set these reels down, you go from 0 amps drawn, right, to 5 cutting units, 100-inch cutting width when these all set down. They all set down and they turn on and they spin right up to speed, full speed, drop right in the grass and start mowing all in one go. So they go from 0 amps to possibly that whole 240 in one instant. And then when you're done, when you end your pass on the fairway, you pick the reels up and that load instantly goes away. You go back to 0 amps drawn. They just turn off. They lift out of the grass, they turn off. And you can watch that voltage here. It actually fluctuates quite a bit. It does exactly what Meckman says it would do. The alternator is supposed to regulate to 56 volts, but really, it'll kind of fluctuate between 50, 60. If you get into heavy loads, I've seen it go down to 40 volts, and I've seen it spike up to like above maybe almost 70 when you pick it up out of like heavy grass. And there's some smaller mowers over there that the same thing. And they'll do the same thing. Those have 48 volt alternators. I've seen them spike up to 60, 70 volts when you pick the reels up. So yes, this alternator is nothing special. It does have voltage fluctuations. And the simple answer is that these motor controllers and motors can handle it. The not so simple answer is that only part of the motor controller can handle it. So one very important detail here is that these motor controllers have 2 parts to them. They have a computer, a logic side, and they have the inverter, the high current side that has the transistors that condition the DC current into the 3-phase AC. And the same is for this controller here. And basically the way John Deere has these configured is only the motor part, we'll refer to it as the inverter, only the inverter portion of these controllers receive that dirty power. And the computer portion, because they are electrically isolated from each other, the computer just controls the transistors. And I'm not an electrical engineer, so forgive me if I'm making this sound stupider than it really is, but the computer portion receives 12 volt power through this big connection here. So these 2 connections are for the motor. You have your 3 phases, and then you have another plug that runs like sensors, the position sensor on the motor and the temperature sensor and other things like that. And then these 2 actually the bottom 2 go to the mower. So again, this is from the alternator, and then this one actually carries that 12 or really 14 volt power, as well as CAN bus communication to actually talk to the rest of the mower. And so the not so simple part of the answer, how they do this, is the sensitive electronics. The computer portion gets its power from this standard 12 volt battery, 14 volt alternator, which is clean power. It's pretty stable voltage, just like any car would have stable voltage. And the inverter part of the controller gets the dirty power from this thing, which has high voltage spikes and AC ripple. And so that's the cool thing about these mowers. So after kind of realizing that, you come back to the cart and you ask yourself, can you do the same thing? Well, it's a surprising yes, because the surprising is that this Curtis controller is not really meant to be powered from two separate power supplies. It's meant to work with batteries, but it does exactly that. And the scary part of this whole project is that I kind of the only validation that this would actually work was just Google AI searches, and I'll put up some screenshots of what Google AI informed me, but you can't always trust that. But long story short, this thing, so the factory cart wiring actually had, so there's a relay down there, and the relay basically acts as a protection for this controller. So the controller receives power. So again, there's two parts to the controller. There's the computer and the inverter. The computer receives low current power from this harness, and then the high current inverter power comes from obviously this large terminal. And this large terminal is actually not always connected. It normally, through the factory, the way it's set up, would actually run through this relay first. So the power, and then of course the ground is shared here. The power from the batteries would, for the computer portion, would be connected before the relay, and then the computer portion is controlling the relay, and then the inverter portion would be connected after the relay that the computer controls. I hope that makes sense, but the point is, this controller already kind of is set up to have two separate power sources, which is interesting, and that's kind of what made this possible. So I've done the same thing as John Deere. So in my cart here, I got the engine. I have a standard 12 volt battery, and just like the John Deere mower has a standard 14 volt alternator, remember this is a small engine, so that standard alternator is the flywheel. Now I did buy a high output flywheel, like charging system, because if anybody knows these Harbor Freight engines, they produce very low charging amps from the factory. But the one I purchased, it came with a special flywheel, a special stator, and even this large regulator rectifier, but that charges that battery at 14 volts. So we have that same setup where we've got a standard 12 volt battery and a standard alternator, 14 volt alternator, part of that flywheel. And so we're powering the computer part of the controller here with the 12 volt system. So I also want to point out a real neat thing about these carts is they have these fuse panels already integrated. The way they normally work is the power comes in back here. Your battery connections would be back here, and this wire, this red wire and this black wire would be again wired, the black wire here, and the red wire before the relay, so it always has power from the battery connections, which would be connected to the relay in here. And this cart, this factory wiring harness, this old one here, would run up to here. It would actually plug in. There was a DC step down converter that converts that 72 volts or whatever to 12 volts, which would feed this panel that basically feeds all those small 12 volt accessories. The only thing that's 12 volts on this cart are the headlights, the horn, which doesn't work, but it was here, and that 12 volt outlet. But now I've done the opposite. So I've got to feed this controller. Now this controller, you can power the computer separately, but it's still designed to work at the typical battery voltage. So this controller is rated for 48 to 80 volts. So I can't provide it 12 volts. I have to provide it 48 to 80, right? So I've done the opposite. I've started at 12 volts And I've added my own step-up converter, which is this thing right here, powered by my 12-volt panel. So this battery is powering, it goes through this is my on and off switch, and later I may turn this into a relay, mount these switches up here to make it nicer. This is my big on and off switch. It powers this whole 12-volt board, and everything gets powered from here, separately fused. So I've done the opposite, 12-volt power, and the same things still work, like the headlights and everything from this board still work just like factory. But now we've added some things, so now we're going the other way. We added this 48-volt step-up converter, and that step-up converter is now feeding power to this computer. So, in essence, that controller, the sensitive part, the computer, is getting clean 48 volts, rock solid 48 volts from the 14-volt charging system. And then the inverter portion, is what's getting the dirty power from that alternator. So we'll show you in the handheld that you can actually monitor this voltages separately in that computer. You can actually see what they call key switch input, which is, it's supposed to be like run through a key switch, but that's the computer voltage. And then you'll see capacitor voltage because there's capacitors in there, and that's the inverter voltage. And so you'll be able to see the two different voltages, how the key switch input one stays solidly at 48, and the capacitor voltage, which is from this thing, is fluctuating quite a bit. And the beauty of this controller is it's rated for 48 to 80 volt battery packs, but it actually that's just the nominal rating. The actual peaks it can experience, it can go all the way down to 24 volts and all the way up to 110 volts. And you can actually program also the margin of error too. Like if maybe you wanted to error out less than 110 volts, but right now I have it programmed to be like 95 volts is too high, and I don't know, I believe like 30 something volts is too low. It's based on percentage, but and then we'll drive it around, and again we can monitor the voltage. You can see it will fluctuate. It sometimes, when you're flooring it and demanding full load and then dropping off that load, it will spike up to like 80 volts. And again, so the answer to this question, how do they make it work? The answer is that controller can handle it, and it works just fine like that. But the computer is not experiencing 80 volts, just the inverter and the motor. So yeah, that's basically one last detail. I also mentioned about the electrical side, that relay that normally is protecting this controller. I am still using it, but not in the same way. So normally it would be, between the power source and the controller would be the relay. You would wire this positive lead. But I don't know what happens. See, I'm not an electrical engineer, so what happens when you have that alternator and it's running, it's producing power, and it's one thing to lose its current draw. Your current draw might go down to 0, and that's fine. It'll spike voltage and steady out. But what happens when you open the circuit with a relay and there's no load anymore? There's no completed circuit. I don't know, it may just freewheel, or it may really spike in voltage. I don't know exactly what would happen. Maybe somebody can tell me. So I decided to do something different though, because I don't want to find out. That's an expensive alternator. That's $1,000 actually. So I don't want to, and that one in there is $5,000, by the way, from John Deere. But I don't want to find out, so I've done something different with this relay. I'm still using the relay, and the relay is nice because this controller is always monitoring conditions, and it'll open the relay when it doesn't like something. It'll protect itself. But instead of opening the circuit, what I've done is use that relay for the alternator's excitation. And so excitation is referring to the power that the alternator needs for that electromagnetic field in the rotor to be, again, it's not a permanent magnet, it's an electromagnetic field that makes the power, along with the mechanical input. But it needs some power, to make power, right? It needs some power to make more power, essentially. Now, in a standard car, or a standard, there in this thing, the standard 14-volt alternator, the initial power just obviously comes from the fact that you've got a 12-volt battery. So that would most likely be this lead right here, and that initial power to excite it comes from, well, there's a battery. But what about the other alternator? Well, the other alternator simply is excited by the 14-volt system. So it actually uses the 14-volt system to excite it, to provide power to that voltage regulator, to that, electromagnetic field in the rotor. Well, what about the Mechman alternator? Well, the Mechman alternator is a little interesting. It is basically the same. I've got the same thing, except this thing requires 24 volts to excite it, which I'm glad Mechman was able to inform me of that. But basically, to provide 24 volts, we're using the 14-volt charging system and using a second step-up converter. So there's the 48-volt one for the controller, and this 24-volt one is for the alternator. And so this power actually runs through that relay and then back to the alternator. And so basically, when the controller shuts the relay off because it doesn't like something, instead of opening the circuit, it just turns the alternator off altogether, and that protects everything just the same. In fact, it protects the alternator, even better than if I was to use a relay. But that's what these two small connections are here. So this is the 24 volts in, and it uses that 24 volts on its regulator to produce 57 volts and a potential of 160 amps. Now this engine maxes out like its power before we produce 160 amps. Another thing about having this controller, this advanced controller here, and this programmer for it, is we can actually set a current limit. So this controller is rated for 350 amps, and with good battery pack and setting it up right, like setting the settings to accelerate hard, this thing will do burnouts and shit if you wanted it to. But this engine and alternator are not going to produce that much current, so we have to limit it. Otherwise, if you were to floor it, you would just stall the engine. So I've set it up where it limits the current perfectly, and it'll load the engine almost to stalling, but it won't stall it. And I do have less power than this cart initially did, and is what it is. This wasn't meant to be performance. This was meant to just make a conceptual piece. So other things so this controller, by the way, the stupid thing about Curtis is they sell different levels of these that maybe the dealer will give golf courses like ours here low levels of these where you can only change so many parameters so that you don't mess with important parameters and then break something. That's understandable, but this is the highest level for this controller, and I was able to purchase it on Amazon for $300. It lets me change basically everything, which is important for two main reasons, or three really. Number one, you want to be able to tell this thing the nominal voltage, which is now 57 volts, not 72, as well as set your overvolt and undervolt parameters, so you can give it the room it needs to spike like it will, but not also set it right so it doesn't super overvolt. Number two, you need to set up the drive currents limits, like I just said, so you don't stall your engine every time you floor it. And number three is a real big one. You need to turn off regen. So this controller does regenerative braking, which is sending power back to the batteries, to slow the vehicle down or hold it on a hill or whatever. There's a lot of functionality with it. But you need to turn that off, because I don't know what happens when you start sending current back to the alternator when it's running. I don't know what would happen. I do know this thing would monitor the voltage increase, and if it gets too high, it would scale back its regen, but I don't know how quickly that response happens and if something would be damaged in the process. But either way, I don't want to find out. So with this controller, you're able to set all the, just turn it all off. And so yeah, that's very important to have this controller and set that thing up right to work in this scenario. Other than that, just to go over all the other little details here, everything up here is factory from this cart, the way the throttle works, the key switch, that key switch is not for the engine, that's just for the controller. And also the headlights, there's two positions. One position is on and the other is the headlights. There is a charge level, and this controller has an algorithm that you can program a bunch of parameters and it'll determine the charge level. And it obviously there's no batteries. I don't know what it's really determining, but that gauge is obviously broken. It's just set to like empty, and that just doesn't matter. The engine start and stuff switch I have here for now. So again, this is the on and off. That not only turns all of the things on, like the controller, the alternator, and maybe headlights, whatnot, but it also turns on the engine. So I have a relay here that's powered by this board, and that relay is for grounding the coil, the ignition coil, the magneto coil, to turn the engine off. So I have ground connected to 30 and the magneto coil at 87A, so the normally closed contact. So it's grounded when the relay is off, and when you give power to the relay via this whole board and that switch down there, it loses the ground, and the magneto is able to build that high voltage to create a spark. And then the starter switch is here. I'll show you that in a little. So you flip it on, start it. And the reason I'm okay with it being under the seat for now is because I've also got the throttle and choke under the seat. Now the choke lever fell off because I'm an idiot, and when you buy these aftermarket deals, or they're normally secured by the factory intake that's here, but anyways, I was driving around and it fell off, but I'm still able to operate it by hand. And again, the throttle's here. Now keep in mind, if anybody doesn't understand, the throttle pedal is for the controller. The actual engine throttle is a separate deal. That's for, in this case, we just leave this engine full throttle, so it has full power, ready to go. It is pretty loud, and probably there'd be a way to automate it, but conceptually this is how I want it, just so the engine has full power ready to go. And we'll talk about that a little bit more at the end of the video, why I made this, why I even would do something like this. But anyways, the point is I'm okay with it under the seat, because all you do, get it started, set your throttle, set it, forget it, and then hop in the seat, turn the cart on and go. Again, this is also factory. The forward and reverse switch works like normal. Factory throttle, factory switch there. So yeah, that's how this works. And then obviously, just some other details, like how I got this small engine in here. Obviously, when you buy these Predator engines and any small engine, they usually have an air filter, exhaust, and fuel tank kind of on top. That obviously wouldn't fit. It still doesn't fit. Again, I had to raise the seat. I'm going to make a permanent metal fixture later, but yeah, but the way I solved all these things is obviously a simple air filter. The tank, I fabricated some mounts on this old battery tray, which is where 2 of the batteries used to go, and so the tank is here. I've added a cheap electric fuel pump and regulator. They work, but they make starting the engine painful, because I believe it actually kind of floods when it's not running. I'll come up with something better. I could just use a vacuum style one, I do need to put like a crankcase breather filter here. The exhaust is a little painful. Now, I chose to mount the alternator where I did because of the frame. Just being, there's a good piece of frame here for me to make that bracket, that supports it, and then there's my tensioner here, and it's a good place structurally. It's a very simple belt system, but the exhaust ended up being painful, so I had to find this special piece that converts to 1-inch NPT. And then I don't have a lot of experience with like actual exhaust pipe bending and welding, but I do have experience with plumbing, so I decided to make this all out of Home Depot special black iron pipe, which works pretty good. And so all it does is kind of just go up and away from the alternator, and this stuff doesn't get too hot from this exhaust. And I've seen small engine designs where the exhaust is close to the belt, and I've even seen one of these E-Cut mowers, like a small triplex, not that style of triplex, and another triplex that has like the E-Cut alternator just like this, with the exhaust running right in front of it. So, I don't know, it actually works. It doesn't get too hot or anything, but yeah, this exhaust runs under, back here, and then up to this old muffler that actually came off of an old gas-powered Cushman over there that's junk now. Yeah, the muffler does quiet the exhaust, but this is still fairly loud because of that intake. This intake makes it very loud. I'll see if I can do something about that later. But yeah, this adapter is from Amazon. Just goes back to 1-inch NBT. And then I did have to make some custom lengths, so those threads and those threads are cut from a die that I tried to do myself. They turned out okay, but not factory quality, but it works. And as for the belt system, you know, normally these alternators come with a serpentine style, like 6-rib belt. But you know, there's not really a pulley available for a 1-inch keyed shaft without like making something. So I was able to find these double V-belt pulleys. You don't want to use a single V-belt. I think there's too much power being transmitted here for a single V-belt, but I was able to find a double V-belt, and these are I believe 5/8 width, section width V-belts, so they're bigger than, you know, they're pretty stout V-belts. They are the ribbed style, which supposedly handle more power and dissipate heat better, and there's 2 of them, obviously. And so I was able to find this pulley for both the 1-inch keyed shaft and for the alternator, and make it work that way, and that turned out pretty solid. I did have to use these little like shaft collar lockers because the set screws don't hold this pulley for shit. But I also, you know, I'm not really a good fabricator, so you can see, just I wasn't careful when I made my engine brackets and my alternator bracket to get these straight. They do, obviously those pulleys are not in line with each other, but these are V-belts. They're a little bit forgiving, and so far it's been working fine. They haven't popped off, they don't slip, and if I ever do wear them out, which it doesn't look like I really am, but if I ever do wear them out, I'll just put new V-belts. It's not a big deal. I'm not even going to use this every day, and it works just fine. And that's kind of the whole deal with this cart. I think I've gone over everything. I've gone over kind of all the specifics of my wiring, the concept. I will go ahead and show it running now, obviously. Yeah, I'll go ahead and start it, and I probably won't talk very much, but because it's very loud, like I said, but I'll show it working, and I'll show the voltages on the handheld. So let me just put everything back, and we'll get it running. And that's the cart. So yeah, you can probably see fairly loud, but you could see how the voltages were working. Again, the key switch one was solid 48 for the computer to be happy, and then the alternator voltage fluctuates quite a bit, and that's totally okay because this thing can handle it. By the way, I wanted to point out how perfectly my exhaust kind of comes out right there. All that's left for this cart is these are junk tires. This is going to property, my parents' property, and I will probably put some like off, traction, like mud tires, right, just to be able to use it, wherever. And it does need an alignment. These Easy-Goes are basically terrible. Aside from the controller and motor, the rest of these carts are really just junk. Under here, there's a throttle box for the sensors, and those go bad all the time. The front ends are junk. The steering rack has probably been replaced. I've just replaced it. The story with this cart is it was sitting junk over there, and my golf course here was nice enough to give me this, let me have it, because they had no plans. The batteries were junk, the steering was junk, I had robbed parts for the brakes, tires are junk. It was a junk cart, but I've obviously restored it, so I've replaced steering rack, and some other things need to be replaced here too, like these knuckles, or the steering knuckle bushings. But it all works now. Obviously, this is not a good cart for the golf course. It's very loud. But again, it's just a conceptual piece, and for me, using it just every now and then on a property, it's gonna be fine. This dump bed, is nice, and yeah, here's the mower. And I might make videos on these golf course equipment one day. But anyways, why would I do this? Why would I? What is the point in this? Well, the point is I've always loved this concept, and one day I want to make a pickup truck like this. So the point of this series, Hybrid, is to eliminate a mechanical transmission, and there's a lot of benefits from that. You get, so you're eliminating the relationship between the engine speed and the wheel speed. The engine speed now just becomes a matter of power, like how much power the engine can produce, and that's what the engine is for. And the wheel speed is totally separate. So that engine just sits at its peak RPM, making peak power, and the wheels, do whatever they need to do with a controller. There's no shifting gears. There's none of that. So how does that translate to a truck like this? Well, let's say you're towing heavy trailer, and these old trucks, like this old Duramax, it has a 5-speed Allison. Now the Allison's a great transmission, but you still got to be in the right gear, and sometimes there just isn't a right gear. Now imagine that old Duramax running at its peak RPM, and you can go any speed you need to. If you're towing a heavy trailer up a hill, or just doing whatever you need to do, the engine speed and what gear you're in and all that crap, it no longer matters. The engine is going to be happy. You don't have to watch EGTs. The engine, you can have a turbo setup that's just perfect for the one engine speed, one power level, and the wheels do whatever they need to do separately with the electric motor controller. Now, there's a company that's kind of popular recently called Edison Motors, and they are doing really great things. They're making a series hybrid, but with batteries, and the whole purpose for their setup is obviously going into the future and being more efficient with diesel, and that's great. That's really a great idea. They're doing great things, but I personally, I'm not a fan of batteries, and that's why I love these mowers so much. We get the benefit of these electric cutting units, which again, the reason why I'll have to make a video about golf equipment, but we get the benefit of them without batteries. And this cart, again, no batteries either. And so batteries, the problem with batteries is they are expensive. Now Edison Motors is using batteries that are standard sizes that you can purchase yourself, and that's very good. But at the end of the day, batteries, and I'm not in any way knocking their idea. They are doing great work. And that is not my point of explaining this. I'm just talking about my personal preference for what I want to do with my truck. I just don't like batteries because they are a maintenance item. Now, nothing lasts forever. Motors don't last forever. Mechanical things don't last forever, but batteries really don't last forever. They have a very, particular lifespan, and there's not much you can do to change that or make it any better or worse than, with maintenance or anything. And so what I want is my old truck, or any old truck like this, old diesel truck, to be a series hybrid without the battery. So I want to have a generator just like this alternator, powered directly by that old Duramax or my old 7.3, whatever, and eliminate the geared transmission that limits the power you can make, and at what RPM and all that, and you lose boost as you shift gears, that sort of thing. There's all kinds of reasons. I think it's just an old way of vehicles working. And instead, I want to see one of these, a series hybrid, fully diesel. It'll still be a diesel truck, 100%. 100% of the power comes from that motor, but instead of a geared transmission, we'd have something like this, an electric transmission. Just a series hybrid setup. No more gears, no more shifting, and just maximum power. Now I don't know, fuel efficiency might go up, might go down. That's not the purpose. Obviously, when you convert to electrical and then back to mechanical, you're gonna lose some efficiency. That's a given. And this thing is no exception. It definitely has less power than the same horsepower engine, just with the old school pedal start belt driven transmission. But for a truck like that, the practicality, the driving quality, it would be great. At least I think it, and it's something I want to do. It's not something I want to sell or market or say anybody else should do, but it's something I want to do. And so yeah, I hope one day, I'm hoping Edison Motors is successful. I'm hoping they'd sell me their electric axle, their motor controller. I believe those two things will be integrated into one unit, but that and their cooling setup and any other kind of electrical I might need for that rear axle there, and I can source an old generator head, or maybe they'll be able to sell me a generator separately too, and basically make exactly what I did here into a much larger scale. So that's why I did this. It's just a concept piece. It's to just for now be able to make something and something cool and drive it around and just see if something kind of works, right? If something makes sense or not. And so far I really like the way this cart works. It is loud, and obviously, and my idea that Duramax would be the same. It would be throttled up all the time, and that's not going to be good for most people who daily drive and stuff. But for long trips and things and towing trailers, that's what I'm thinking of. And of course, the throttle can be automated somehow. But anyways, that is the reason why I would do something like this, and I just figured I'd share that. So, yeah. Anyways, that is my series hybrid cart. I just wanted to make a video documenting it because I think it's pretty cool. Maybe somebody else will think it's pretty cool. And yeah, hope I didn't talk too much. Thank you.